Hello students, once again welcome back to these Misostudy video classes, and today's topic is combination of gates. Well, all those students who are regularly watching our videos, they will easily find out that this topic is actually associated with the previous lecture. Why? Because just before this lecture I provided a lecture on logic gates. So, what types of gates we have in semiconductor material devices? So, we have three basic gates, that is AND gate, fine, that is represented like this, fine. Then we have OR gate, that is it is multiplication, it is represented like this. It is what? It is summation. And one was NOT gate. NOT was represented like this, fine, and it was for negation. So, these were three basic gates, and I explained properly their truth tables and all other associated concepts. Actually, there I mentioned few combinations, just introduction. So, I thought I realized just on the basis of the demand of few students that I should tell something more about combination. Combination means combined and not, combined not with or, combined not with this or and not. So, something like that, clubbing these three gates together. So, there are you can say other combinations of these logic gates possible. That is why I mentioned combination of gates. This may be combined with this may be combined by this may be combined with this, and so on, fine. So, now today I am going to explain certain combinations. Although I explained, at least I mentioned the names of these combinations, one or two names in the previous video, but today specifically I will explain this entire situation. Students, this chapter, that is logic gate, this topic basically is important not only for your board exams, there it is really very important, fine, but for your medical entrance exam and IIT JEE mains exam, this topic is very important, fine. So, simple and important topic. If you put a small amount of not stress but attention, you will understand this topic. So, first combination is defined as NAND gate, fine. NAND means not plus and, NAND, that is not plus and, means if you add NOT gate with AND gate, you will get NAND gate, fine. So, what exactly you can is the method of realization? So, first is this is your AND gate, fine, this is A, this is B. Try to recall, I mentioned that these gates has two or more inputs but one output, fine. So, over here this is AB and this is Y prime, that is output of this. Then add one NOT gate and here you will get output Y, fine. So, one output is Y prime and then actual output is Y. Another way of representing this gate is this is AND gate, fine. If you do not want to draw this big circuit, you can say this is A, this is B, then place a hollow circle and then it is your Y. Now, here remarkable thing is what? Please pay attention. I am using a red color chalk. If the dot is small and solid like this, please listen carefully, it is input, it is output, it is output. But if my this dot is hollow, circle like this. It is the symbol of negation or NOT gate. So solid means no logic, nothing like that, only output or input, but this is logic, that is NOT. So this is also the way of representing NAND gate, NOT plus AND, fine. Now then important aspect is truth table of this NAND gate. So this is the truth table, 1, 2, 3, 4, okay, 4 columns, and then I should draw 1, 2, 3, 4, 5, I think, yes. This way it is going to be easier for you to understand. 2, 3, 4, 1, 2, 3, 4, I think I should increase it downwards slightly. I hope it is visible to all of you at the bottom also, fine. So let me allow to add it up. So now you have a table, that is A, B, Y prime, Y. Now let us start putting the values. So 0, 0, 0, you will get 1, that is low, 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 high, fine. Then high, low, low, it will give you high. Negation, not only AND but with NOT. Then it is low, high, low, I think it is actual combination, yes, low, 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 1 high, 2 low, yes. So this way also it is high, fine. Then remaining combination is high, 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 low. So this is the you can say outcome of NAND gate. Now if you are unable to visualize it, just for the time being forget this much table, fine. Let us apply AND logic over here. AND means when both inputs are high, only then output is high, fine. So low, low should be low, 1 high, 1 low, low, 1 low, 1 high, low, only high plus high, high plus high multiplied by high will give you high. But reverse of this should be here, low, high, low, high, low, high, high, low, fine. So this is NAND gate, this is symbolic representation, and this is the truth table. Then comes, students, another is NOR gate, okay. NOR gate means NOT plus OR. If you add one NOT gate with OR gate, then you will get NOR gate, fine. Now first is what is the symbolic representation. So just on these lines, fine. I think I should add these red arrows over here also. Now beautiful, oh, fine. So just on the basis of these lines, what I will do, first I will draw OR gate, fine, like this. From OR gate, output is, let us say, Y prime, fine, and from this output of Y prime, I added one NOT gate, fine, the symbol is like this. So this NOT gate, I think I should add this arrow over here also, this way. So similarly this way, this is solid dot, fine, and then it is Y, and repeatedly I am putting like this. So it is A, it is B, or you can draw it also like this way. It is Y. Fine. Both are symbolic representations. Now I use blue chalk. It's up to me to use blue, red, green, yellow, whatever I want. Point is, the diagram should be clear to you. So this is the circuit or symbolic representation of NOR gate. Now once again I need a table. Fine. So for this table, yes, once again I think I should draw the table in totality. Fine. All the inputs outputs in one table. 2, 3, 4, 5. Fine. 2, 3, 4. Okay. So now A input, B input, Y prime. Fine. And it is Y. Let's start providing the input. So we can use the same type of logic over here also, the way it is represented. Fine. So let's say low, low, low. In OR gate, if both inputs are low, your output is going to be low. But because it is negation, so it is high. Then second one, I want to use so many colors. Now this is high, low. So it is high, it is low, it will give me high, but its outcome is going to be low. Fine. Then it is low, high, it is high, and it is low, high, high, it is low. Then it comes high, 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 low. Yes, high, 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 low. Fine. So this is your NOR gate. Now in these two gates you can realize that our basic gate is OR. Fine. And if we take a look in this diagram, then over here our basic gate is AND. But just by adding these two you can say NOT gate, we realize this truth table, and this is the symbolic representation. So there is one next combination, and what I will do, I will use this combination. I think I should erase out, then I should explain. Combination of gates heading we need, so let it be remain like that. Then comes exclusive OR, XOR gate. XOR means what? Actually, XOR and OR difference is what? OR means even if one input is high, the output is high, and if both input is high, very good, balle balle, that is also going to be high. But exclusive OR is saying if and if only one input is high, then output is going to be high. If both inputs are high, then it is not exclusive. It's like that, exclusive either tea or coffee. It's not like that you can take both. Fine. So exclusive OR is associated with the values where only one value is high. So let's consider the scenario of this particular situation. Exclusive means, let's try to draw a big diagram. Fine. I have one AND gate over here, and I have one AND gate over here. This is, you can say, first slightly complicated circuit diagram. The output of both these gates going to OR gate. Fine, symbolic representation, OR gate. So output is going to be like this. Fine. And I should use a red color chalk to show you this is y prime and this is y double prime. Now back of this is AND gate. Fine, sorry, this is not and this is connected over here. Similarly, this is NOT gate connected to this AND gate. Then input of this and input of this should be fed over here. Fine. So this is A, this is B. Now this input should go over here. How? I think I should use a different color chalk. This way, like this and this. Fine. This is one aspect, and let's use this red color, forbidden red color chalk. So this input will go here and then added like this. I hope this diagram is beautiful enough. But if you want to create a simple circuit for this big circuit, you can draw it also in this manner. Fine. This is also the symbol of exclusive OR gate, A, B. So either draw this or draw that, it's up to you, no problem. Now I need a truth table for this. So this truth table is simple one. Fine. Just I need a small space to show you this table. So this is 2, 3, and if I am adding one more column over here, I hope it is also visible to all of you. So then 2 and 3. Let's start putting the values. That is A, B, and this is Y. A, B, and this is final outcome Y. So low, low, low. Fine. I have to add one more because A, B is excess, but anyway you can understand it. So this is 1. I am not writing each and every response, just few responses like this, high, and then high, high, and low. I think this is the most important aspect, this one. Fine, this is most important aspect. So this is the scenario in which we can say we can discuss exclusive OR gate. Fine. Then next I have another gate, that is XNOR gate, that is exclusive NOT plus OR gate. So you can say 3 terms are associated: exclusive, NOT, and OR. Fine. So what is the symbolic representation? The symbolic representation in short is very beautiful. Only add one NOT gate, otherwise everything is similar to exclusive OR gate. So this is Y, this is A, this is B. Fine. What is the truth table of this gate? That is, let's write it like this: 0, 0, 1. Just few terms I am writing. Then 0, 1, 0. Fine. A, B, Y, you know that. Then another I can say 1, 0, 0. Fine. Like this. Fine. So this way you can complete this truth table for this particular logic gate. All values I not mentioned. One more important aspect, yes, I think I should mention that. That is important. That is, the difference between exclusive NOR and exclusive OR is high, high, high. Fine. And here, just take a look over here, high, high, low. So this is the difference. Fine, because it is exclusive NOR gate and that is exclusive OR gate. Fine. Now obviously I have to tell you something more over here, and whatever the knowledge I am giving, knowledge or explanation or topic explanation I am giving you, please try to maintain all these points in the form of notes, either in your mind or in your notebook. Fine, because that is something which is really going to be helpful for all of you at some point of time, whether your board exams or some other exams. This much detailed explanation of this topic almost you will not able to find out in general. In this small amount of time I am trying to pick up all these possible aspects. Fine. Now if you try to recall, in this previous video I mentioned Boolean expressions, Boolean algebra, certain terms I mentioned. So let us say a question is given in terms of this Boolean expression. So how you can find out the solution of that particular question? Let A, B, C are three logic variables. Fine. Prove Boolean identity. No question is going to be beyond this much difficulty. ABC are three logic variables, prove Boolean identity. And what is the identity? A dot B dot C plus A dot B bar dot C, fine, plus A dot B dot C bar, yes, plus A dot B dot C bar is equal to A dot B dot C, A dot B bar C plus A dot B bar dot C. Prove A dot within bracket B dot C. Let us say we want to prove this identity. So let us start from left hand side and then prove right hand side. So from LHS, left hand side, we can write down after some, you can say, minute changes, C plus C bar plus B bar dot C. Yes, C plus C bar is equal to 1. So I can write down A dot B dot. Now it is 1, so there is no point of writing this. So A dot 1 plus, no point of writing 1, that is B bar C. Fine. From here what we can write down? We can write down A, then within bracket this B bar C. Fine. And as you know, this change will give me out over here, that is A dot B plus C. So this is right hand side. Now these type of questions you can do just by revising up to some extent. What exactly? That is exactly this explanation of Boolean expressions or Boolean identity. In previous video I provided all relations. Fine, and just for the sake of that revision I am putting this question. Another issue you can say, how AND gate can be realized by, how AND gate can be realized by NAND gate. Let's say I have NAND gate and I want to create AND gate. So how I can create it? Fine. So we can create it like, first take NAND gate. Fine. This is number 1 is NAND gate. Input, A, B. Now this output this way, fine, let's say it is Y prime. So this output now added with both inputs of another NAND gate and then it is Y. So take two NAND gates, fine. In one NAND gate give individual variables and then the outcome should be added in both inputs of another NAND gate. So what you can say about first? You can say this Y prime, Mr. Y prime is nothing but A dot B bar. Simple. Then for this 2, this is second NAND gate. So for this you can say Y is equal to Y bar dot Y true. Take the look of this and this will give you what? It will give you A dot B bar within bracket A dot B bar, that you can say A dot B double bar plus A dot B double bar. Fine. So from here I can say A dot B double bar plus A dot B double bar. Now if Boolean expressions and identities are not clear in your mind, whatever I am writing is meaningless for you. But if those things are clear, you will close your eyes, you can listen a song, you can solve all these problems. It's so logical. Fine. So A dot B double bar plus A dot B double bar, the relation I provided. So finally what I will say, it is A dot B plus A dot B. Now AND gate is something that you will get from here, A dot B. So that is, you can say we can realize AND gate from NAND gate using these two NAND gates. There are so many possibilities in this particular situation. One more question just to give you the understanding. You can say it may be like and from NOR. You can create AND gate from NOR gate. How you can do that? Just use this value like this. This is your Y and the input of this gate is given like this way, and one more gate that is this way. Fine. Now outcome should be added over here, and both the inputs A and both the inputs B. So this will give you the realization of AND gate from NOR gate. How? You can say, let's say this is Y1, this is Y2 and this is Y. So what you can say, that Y is equal to Y1 plus Y2 bar, that will give you A bar plus B bar whole bar, and ultimately it will give you A double bar dot B double bar is equal to A dot B. So simple situations over here that with the help of Boolean expressions and all these things you can calculate. So students, this is all in all in this particular chapter. So now I think we should stop over here with this point. I would like to remind you, please revise these things which are really very simple. So with this hope that you will keep in touch with the subject, you will enjoy your knowledge, you will gain more marks in your exams. I would like to say thanks to all of you for this class.